Hello everyone, Assalamu alaikum. Welcome back to Dr. Teeth. Now, this is my first Dr. Teeth note. Can you see that? Is it nice? I'm really liking it. Anyway, I know I have to improve a lot. But let's start with this video. Today we are going to learn about the direct retainers in the cast partial dentures or the removable partial denture. Now, these notes will be available on our website. I'll share the link to download these notes in the description box of this video, and also in the upcoming videos. I will try that each video has notes with it so that it gets easy for you to, revise it, right? Because you cannot always come back to the video and watch it again, right? So first we need to understand what are direct retainers. So it is the component of the removable partial denture that engage abutment and resist the dislodging forces, right? So let us suppose this is our abutment teeth. What is an abutment teeth? It is any teeth from which we are going to take support for our prosthesis, right? So that is called the abutment tooth, okay? So the direct retainers is that component which will engage the abutment. And why we need to engage the abutment? Because we want to resist the dislodging forces. Now these direct retainers, they are of two types. We have the intracoronal and the extracoronal. So we have two types of direct retainers, the intracoronal and the extracoronal. Okay. So as the name suggests, what do you mean by intra? Intra means within, and coronal means the crown. So the intracoronal retainers, they lie within the confines, or you can say within the limit of the crown. So let us suppose this is our crown. Okay. So the intracoronal retainer, what they will do, they will just lie within the confines or within the boundaries of the crown. Okay. But what about this extracoronal? So they will lie outside the crown. So you can imagine that it could be a clasp, or it could be something else. And that something else we'll see, right? I'm not going to complicate it right now. So just understand that extracoronal is outside the crown, right? Now this intracoronal, it is of two types. We have the precision attachment and the semi-precision attachment. Now what do you understand by the term precision? Precision means it's very precise. Now how can something be precise? If you have manufactured it very well, the manufacturing process is very precise, that is a precision attachment, and that is why we have given this name to it. So if the components are made in metal using high precision manufacturing techniques, we get precision attachment. And what is semi-precision attachment? Now semi-precision attachment, they are not very precise, they are semi-precise, you can say. How? Because first we make a wax pattern or a plastic pattern, and then we subsequently cast it in metal. So that process of making it, it is not very precise. So the result is also not precise. Like if you are not putting your 100% in your study, you cannot expect a 100% result, right? So similarly, we have a semi-precision attachment here. So intracoronal is of two types, precision and semi-precision. Now the extracoronal direct retainer, they are of two types also. We have extracoronal attachments and retentive clasp assemblies. So let's begin with the intracoronal direct retainer. Okay. Now the intracoronal direct retainer, it was introduced by Herman E.S. I leave this pronunciation to you, in 1906, if that is important. And we have seen that these retainers lie within the confines of the tooth. Okay. So as you can see here, we have two parts of this retainer. We have a patrix and we have a matrix. So this matrix, it is contained within the contours of the crown, as you can see here, right? And this patrix, this is an extension that will go and fit into the matrix. Okay. So you can remember patrix with Papa and matrix with Mama. So always Papa has to go to Mama when she gets angry. So patrix goes to the matrix, right? And it obviously fits there. Now this intracoronal direct retainer, it can be precision or non-precision, as we have already seen. Now coming to this diagram right here. Now this diagram here, I've tried to show the parallelism of different tooth. If you have multiple tooth, okay, like if you have to place multiple intracoronal attachment to many teeth, it is very necessary that we have parallel preparations, okay. So the matrix and the patrix has to be parallel when we have multiple tooth that will have them. So why should they be parallel? Because when we have parallel walls, we will have well-defined path of insertion and removal, okay. And also such parallel walls, they will help in mechanical binding, okay, because of friction. And that is called as the binding phenomena, okay. So I'm just going to highlight this. Now let's talk about the precision versus non-precision. We have already discussed this, but let's do it once more. So precision is made by high precision manufacturing, but in the non-precision, first we have a wax or plastic pattern, and then we cast it in metal. So because of the manufacturing process, this one is very precise, okay, but this is less precise, okay. Also these attachments, they have long parallel walls and they have a very, very amazing surface adaptation. And here we have a slight tapering wall. Now let's move on to the extracoronal direct retainer. As you can see here, it is lying outside the confines of the tooth, okay. This you can imagine either buccally or lingually, not within the tooth, right? And this is obviously not within the tooth. So it is extracoronal, okay, lies outside the tooth. And we have seen that it is of two types, extracoronal attachment and the retentive clasp assemblies. Now this is also of two types. We have the Suprabulge and we have the Infrabulge. We will see what that means. So first we will talk about the retentive clasp assembly. So this is just about the different types of clasp about which you might have, heard about or, seen, but we will see that, okay. One thing I forgot to mention is that the extracoronal attachment was introduced by Henry R. Booz or Bose, I'm sorry, 1900, in 1900, right? I thought I should mention it because I've mentioned about the previous one, the intracoronal one. Okay, so this right here, it represents a clasp. Now, the clasp can be divided into three parts. We have, now let us suppose we have a tooth right here, okay. This looks like a Starbucks coffee. Anyway, so let us suppose this is our clasp, okay. So it can be divided into three parts. We have one that is the proximal 1/3, this is the middle 1/3, and this is the terminal 1/3. So this terminal 1/3, it is somewhat flexible. And why this flexibility helps? Because, so let us suppose this is the greatest curvature of this tooth, means from here it is very bulky. Now when we have to insert this clasp or say insert our CPD or RPD onto the tooth, what will happen? Since this is flexible, this will easily pass through the greatest curvature, okay. It will change its shape little bit, and then when it reaches apically, it will again come back to its original and it will sit here passively. I hope I made it clear. Now let's have a look at this diagram. Now here in green you can see we have a survey line and this is our clasp. Now we have seen that the clasp is somewhat flexible. Now when we place this prosthesis here, what will happen? Now as you can see here, this terminal portion, this clasp terminus, it is contacting the abutment apical to the height of contour. So because of this, the dislodgement will be prevented. And also note that at this position, the clasp is now passive. Means once our prosthesis is fully seated, this clasp will not apply any unwanted forces on the abutment teeth, which is a very good thing. Now let's talk about something that is Prothero's cone theory. What is that? So Prothero was a name of a person and he introduced this theory. So in his theory, he said that the crown is, made by nature in such a way that it resembles two cones which are placed by their base facing towards each other, as you can see here. So this is the height of the contour of the tooth. Means here you will have a greatest dimension of our tooth. It will be very bulky here, you can imagine, okay? And above it and below it. The above it portion is the suprabulge, okay? And the portion below the height of contour is known as the infrabulge. So here you can see this right here, this cone is the suprabulge and this cone represents the infrabulge. Now this height of contour, it is the junction of the occlusal and the cervical convergence. Now when you see this tooth from the occlusal view, let us suppose this is the occlusal view and we have the anatomy, right? So this greatest diameter of the crown is the height of contour. And why are we seeing it from top? Because that is the proposed path of insertion, right? You will place the prosthesis from top. So it is very logical to understand that whenever we have a clasp terminus here, right, below the height of contour, since the diameter here is more than the diameter here, obviously it will not be able to lift very easily because it is a metal after all, right? So it cannot easily change its shape and lift. That is why we are getting a retention, because we are engaging an undercut on the abutment. And based on these two terms only, we have the suprabulge and the infrabulge clasp. The clasp which engages the tooth from the superior side, that is the suprabulge, and the ones that engages from the apical portion or infra means below, right? So that is the infrabulge. So with this we come to the types of the clasp. We have the suprabulge and the infrabulge. The suprabulge is also known as the Ecker's clasp after Dr. Paul E. Eckers, or circumferential clasp based on its design. And the second type is the infrabulge, also called as the Roach clasp after Dr. F. Ewing Roach, or the bar clasp. Now let's see the types of the suprabulge clasp. Let me zoom out. So here we have some designs. We have the simple circlet, reverse circlet, because you can see this is reverse of it. And we have the C clasp. We have the embrasure clasp because it is engaging the embrasure. And then we have the onlay clasp because it is kind of like an onlay, right? You must have learnt about the inlays and onlays. So this is the onlay clasp. We will learn about them, in detail in subsequent videos. But in this video, we're just going to see an overview. Okay, so we have some more. We have the multiple circlet, as you can see. Okay, so this is the buccal view. This is the buccal view. This is the lingual view. And when you see it properly, means lingual view, it will look something like this. Okay. And we have the ring clasp. Okay, it is like a ring. So those were the suprabulge clasp. Now we have to talk about the infrabulge. Okay, as you can see here, it is approaching the tooth from the inferior side, right, below the height of contour. So these are the infrabulge. We have the I clasp. It resembles an I. We have the modified T. You can say half T, and this is the full T. So that is the T clasp. Now a question is, what is clasp assembly? Okay, in school, I remember the first time I heard assembly, and also you might have heard it for the first time there as well. So assembly is kind of a group. Okay, so what is a clasp assembly? So it must be a group of something, right? So clasp assembly is actually made up of these things. We have the rest, we have the retentive arm, reciprocal arm, minor connector, okay, and also we have some specific design features like approach arm. So these approach arm, you will find this in the infrabulge clasp, not in the suprabulge. Okay, so clasp assembly is a combination of rest, retentive arm, reciprocal arm, and the minor connector. So let us see the clasp assembly of the suprabulge clasp. As you can see, this is the rest. So on the abutment tooth, we prepare some depression or you can say a pit sort of thing that is called as the rest seat. Okay, and within the rest seat, the rest of the clasp will engage. It will fit in here in the depression that we create while doing mouth preparation. So that is the rest, and it provides the vertical support to the prosthesis. Okay, I'll just mention it here. Vertical support. I think I have mentioned it in the note somewhere. I'll see. But anyway, I'll just mention it here. So it provides vertical support, and generally rest is located on the occlusal surface of molars, premolars, or if it is a canine, it will be located at the cingulum of the canine. Okay, and also on the incisal edges of mandibular incisors in some cases. Okay, so that is about the rest. So the rest provides vertical support, so it will not allow the prosthesis to sink inside, because we have a stop here. It creates a stop here. Okay, so it will resist the displacement of the prosthesis towards the supporting tissues. Okay, and also it will transmit the functional forces parallel to this abutment tooth or any abutment tooth, okay, on which we have placed it. What it will do, it will transmit the functional forces parallel to the long axis of the abutment. Then we have the retentive arm. We have talked about it a while ago. This is the portion of the clasp that goes apical to the height of contour. And these retentive arms, they can be either suprabulge or infrabulge. So it depends on their approach. Either it is approaching from top to bottom, or it is approaching from bottom to top. Means apical to occlusal, right? So this is the retentive arm. Now this right here is our minor connector, okay, and as you can see from the minor connector, the clasp is originating. So this portion right here, this is the portion of the minor connector from which the clasp is originating, okay, that is known as the shoulder, right? So the portion of the clasp that will arise from the minor connector, right, that is known as the shoulder. So this shoulder, this is rigid. I'll just mention it here. I've not mentioned it. This shoulder is rigid. Okay. Now this midsection is somewhat flexible. Why? You can see here that from here to here we have a tapering. Means it is getting thinner and thinner as we move downward. Okay. So because this is thinner compared to this one, it will have somewhat flexible nature. Now coming to this portion, this is the terminus. We have talked about it, remember? So it has even more smaller cross section compared to this one, and it has the greatest flexibility. So this has the greatest flexibility. Now coming to the infrabulge clasp, as you can see here, we have the rest. So I have color coded this to make it easy. Let me know in the comment section below if you find this type of drawing helpful. I tried my best, though I'm not a good artist, but still. So this is the rest right here, green. Then we have the retentive clasp. This is the clasp terminus, okay. And then this right here, this is the reciprocal element, okay. This is the horizontal approach arm, because as you can see, it is kind of horizontal, right? And then this is the vertical one, okay. This is the vertical one. And then we have this is the minor connector, okay. So as you can see here, we have the horizontal approach arm and vertical approach arm in addition. So these are specific design considerations, right? And if I have not talked about this term, this is the reciprocal arm. So as the name suggests, it is just the opposite of the retentive arm. It was lying below the height of contour, but this lies at or occlusal to the height of contour. It will lie above the height of contour or at the height of contour. And what it does, during the placement and removal of the prosthesis, this reciprocal arm, it will brace the abutment, okay. It will kind of hug the abutment. The presence of reciprocal arm is very important. So while inserting the prosthesis, if we just have this retentive arm, okay, so whenever it will try to pass through the height of contour, we have seen that it will flex a bit, okay, because it has to pass through a greatest diameter, right? It will flex, means it will change its shape a little bit, and then it will come here, and then it will come back to its original, shape and engage here. But when it was flexing, when it was changing the shape because of the diameter, this will apply lateral stresses onto this tooth, okay? So to counteract that lateral stress, we need the reciprocal arm. If we have the lateral stress, the abutment will, it will have detrimental impact on the abutment. That is why we are placing the reciprocal arm just opposite to the retentive arm, and also the position is occlusal to the greatest height of contour, or at the greatest height of contour. I hope I made it clear. I'm not using animations because it already took me a lot of time to make these notes, and if I just sit down to edit this, I don't think I'll be able to post a video even in 2 weeks. So I'm really sorry for that. Hope you understood. Let me know in the comment section below, please, if you feel that you are able to understand this way also compared to my previous animation. I'll try to put animations also in the upcoming videos. Let's see how it goes. If I have time, I'm just now focusing on the notes. So fingers crossed. Also, I would like to mention here that during the insertion of our prosthesis, this reciprocal arm, it should contact the abutment slightly before this retentive arm contacts the abutment. So before this could contact the abutment, this should contact the abutment when we insert the prosthesis. And while our retentive arm is passing through the greatest height of contour all throughout, this reciprocal arm should contact the abutment. That is how it will prevent the lateral stresses. So always make sure that the retentive arm should never contact the tooth before the reciprocal arm. Why? Because if this happens, there will be non-axial forces on this abutment tooth, and that will be damaging. So this is kind of a summary. Rest provides the vertical support. The retentive clasp, it contacts the abutment apical to the height of contour, right? And the terminus of the clasp, it contacts the undercut. The reciprocal arm, it contacts the abutment during prosthesis insertion and removal, and it is above the height of contour, okay? Then we have the horizontal and the vertical approach arm and the minor connectors. Now for minor connectors, let's keep in mind that they have to be rigid, and they may have different functions based on different cases. Like in some cases, it can act as a guiding plate. Let us suppose we have two tooth right here, okay, and we have a edentulous space here. We prepare, or you can say we grind little bit of the tooth, abutment tooth, and we place our minor connector here, okay, along with the prosthesis, right? So this acts as a guiding plate. It helps in the insertion and the removal of the prosthesis. It may also act as a reciprocal element to balance the forces, and also it may act as horizontal approach arm and vertical approach arm in case of the infrabulge clasp, okay. So that was all about the direct retainers. In the next video, we will study about all these, clasp in detail, and the notes of this video will be available in the link below. So you can go there and download it. And also please let me know in the comment section below if you find this study method helpful. I will be only able to improve if I have your feedback. And also if you're new here, please consider subscribing and also share my work to help support the channel and this platform. I'll see you in the next video. Take care. Al Hafiz.